career, he is engaged with prestigious companies like SCO and Oracle Technologies while working at different levels on operating system and platforms. He sought extensive experience overseeing implementation and management of critical systems. This experience has helped him develop a range of relevant skills, including an in-depth knowledge of Linux and Unix server architecture, confident project leadership, and familiarity with a range of technologies. He transited to Stratus Technologies, a company with hardware and software redundancy solutions in 2005, and has been a trusted advisor to many organizations in BFSI, manufacturing, space, and atomic research field for their redundancy needs for critical environment. Shivanand's leisure pursuits are that he's a passionate traveler and a biker. Very good morning and welcome to our webinar, Mr. Shivanand Wagner. I would now like to introduce Lee Ho Fung. He is the Managing Director for Stratus Technologies in South Asia and ASEAN emerging countries. A veteran in information technology and technology-enabled services industry, Lin Ho brings with him a wealth of experience in IT infrastructure, consulting, strategic IT outsourcing, and software solutions across numerous verticals, including public sector, telecommunications, financial institution, and most recently into operation technologies in the industrial automation segment. Lin Ho Fung holds an executive MBA as well as an B Engineering Honors degree in communications and electronics. He is presently based out of Singapore. We welcome you, Mr. Fung, in our webinar today.
Thank you, Deepak.
And now I would like to introduce our Vice Chancellor, sir, and Professor Dr. S.P. Singh. He's our Vice Chancellor of the Royal Global University. He has been associated with the Royal Group from its inception in the year 2009 as the founder director of the institution. He further moved to Amity Education Group in 2013 and joined as their Senior Vice President Academic of the group and was responsible for functioning of 6 Amity campuses situated in different parts of the country and abroad. He also served as the founder Vice Chancellor of Amity University, Chhattisgarh for almost 2 years before joining the Assam Royal Global University in November 2016 as the founder Vice Chancellor. With the vision and hard work of Professor Singh, the university has been ranked as the #1 private university of Assam by Education World within a span of just 3 years. And with more than 3 decades of rich experience in teaching, research, academic administration, in institutions of repute across the nation, Royal Group is blessed twice to have the association of Professor Singh in his journey so far. While serving his second tenure as Vice Chancellor of Royal Global University, Professor Singh has completed almost 20 years of headship of well-known academic institutions of the country. A geologist, MBA, and a law graduate with PhD in strategic management, Professor Singh is also an ardent baseball player and has been actively involved in various social and cultural activities since his heydays in the university. A very good morning to you, sir, and welcome to this webinar. Sir, over to you for your introductory remarks.
Thank you so much, Deepak, and good morning to all participants and especially to 2 eminent speakers and panelists for the day, Mr. Lee Hui Fong, and who's all the way here from Southeast Asia, and he is Managing Director of Stratus Technologies, and also Mr. Shivanand Wagle. Shivanand Wagle. Shivanand Wagle, who is also electrical engineer from Pune University and who's here in this webinar. So before, because Dicom, I have a little less time today, I'll be with you all for another 15-20 minutes.
Right.
But then I request that please ask Hirak Ranjan and all the other departmental heads of engineering to request students and other participants to join in soon, because I'm just going through the list of participants. It's quite feeble with respect to Royal Global University. So if you request Shashank and Hirak to ask students and faculty members to join in. However, as far as this topic is concerned, my journey as such is not in the field of computing and computer science, but we all are dealing with computer and computer science on day-to-day basis. And we also have so many things in life to decide about IT infrastructure, also to take decision with respect to benefit of the university, benefit of the institution and students. And we are very eager to know more about cloud computing from quite some time, last 2-3 years. Now, a new thing you have all said about edge computing. So I don't know cloud computing, then edge computing. This all is French and German to me. But whatever, I think end of the day, we do sitting at the level where we have to take decisions with respect to the institution's benefit and with respect to benefit of all. We at times are suffering with the issues of lock time and also bandwidth. I think lock time and bandwidth and bringing clouds closer to the user, and also related to the how cloud can be or the data can be distributed, and data can be distributed and can be utilized for the benefit of the user, and how quickly it can be done, so that the lock time and also the bandwidth, it uses low bandwidth and lock time. This is little bit I know about your edge computing, and that is my limited knowledge. I may be excused for that, but this is the only thing I know, that this is having some edge on already existing cloud computing. Cloud computing is basically to store the data somewhere and store it, and maybe you require whenever you can pull it out, and you can have some other activities. But then edge computing is a little smart, or maybe more diversified, where you can bring cloud closer to you and you do the things, so that lock time and also the bandwidth. This is because there are many platforms we use. We use Zoom because it uses a minimum bandwidth. I'm just giving an example. Many other, we use WebEx and we use other things. They use at times a lot of bandwidth, or maybe I don't know exactly, but that I've been told to me by my IT team. So this is good because this uses low bandwidth, this uses high bandwidth. So all those things are known to me, but I may be excused. I don't know beyond that. So this is little bit I wanted to. But what I am saying is that I am very inquisitive to hear from you all, to learn more. Though as a vice chancellor, probably I have so many people to brief me about certain issues, but that is not enough unless and until you know more about a particular domain and any area. So therefore, I'll be attending for another half an hour or 20 minutes with you guys, and will like to know more from Mr. Fung and Mr. Wagle, something more about edge computing. So Dicom, this is all from my side. All the best to the participants, and I think the numbers are increasing. To the participants especially, please try to listen to these two people and try to learn more. I am still a learner, and we talk about in new national education policy lifelong learning, but at times when it is a learning time, we shy off. I don't know why, but somehow I am always ready to learn more and new things, and I expect my students and faculty members also to be like that, and I hope they will learn many good things, new things from today's webinar. So over to you, Dicom, and a very good morning to all of you again. Thank you.
Thank you so much, sir, for your welcome address. It's indeed a privilege to have Mr. Fung Li Ho and Shivanand Wagle with us today. And I'm sure our students and our team here will benefit out of their immense wealth of experience that they bring in into the field of IT and infrastructure consulting, along with strategic IT outsourcing and software solutions. And now, to hear straight on these lines of edge computing for business critical and industrial applications, I now request Mr. Fung Li Ho of Stratus Technologies, who is the main focal point there, to address all of us. and share his experience. So over to you.
Thank you, Decom, and thanks, Professor SP Singh, for having us. Let me just try to share my slides before we start. Just give me a second. Can you all see my slide now?
Yes, we do.
Fantastic.
Yes.
Okay, first of all, very good morning. I think Mr. Professor SP Singh, you have really set the stage for me. I mean, thanks for kicking off with some pointers there. What's the difference between cloud computing? What is it now with edge computing? What's the difference? So this is indeed a session where we'll share a little bit more insights. May not be across the board. I've actually chosen a very specific topic targeting the manufacturing space, but of course, if we want to, we can choose a separate timing to talk about a broader aspect of how edge play in everything, namely be it in IoT, be it in smart cities, and so on. It's just that today we have actually chosen a topic to talk about business critical industrial application. So that's the topic for today. All right. Now, first of all, I know the pandemic issue in India is really not in a very good state. The last I read the news, it has surpassed 5 million of infection. So I hope everybody is staying healthy, staying safe, regardless of where you are. I'm sure we can ride through this situation in due course. But the vaccines are on the way, I believe. So let's actually pull this through together. Right. Now, first of all, before I get into details, let me just share with you the topics that I'll be going through today, right? Like I say, it is very much around manufacturing challenges in the manufacturing space, in the industrial automation space, how the different challenges has been so-called shifting as a result of the pandemic situation. So that's what I'll be going through. And of course, how the new norm will be driving the digital transformation. I believe all of you have actually heard about digital transformation. For the IT space, for the longest time, everybody should be going for digital and so on and so forth. What we are talking a little bit today is really about digital transformation in the industrial space. So, and how the new normal is actually driving the different demands differently. Okay. Now, of course, then I'll share a little bit about 3 quick win strategy for edge computing, followed by closely what to look out for when it comes to edge computing provider. And then only I'll talk a little bit about Stratus, what we do and how we help our customer. So that's actually what I'll be doing. Right? Now, first of all, these are the very common challenges that we have been experiencing almost the last 5 years, if not 10 years. It's nothing new, if you ask me, right? What are the typical manufacturing operational challenges today, right? It actually cuts across from, let me just bring out my laser pointer. Okay, it cut across from the complexity of the processes, the different industry plants are actually having to actually manage. Some will call it having digital silos. How do you actually integrate them? Whether you can actually have a certain part of a plant flowing information across to the other part of the assembly plant and so on and so forth. So that's continued to be a key challenge that manufacturing operations is having today, right? Workforce. The last I checked, when I look at India workforce population, it says that only about 50% of the workforce is actually coming from the urban area, right? And if you actually move down a little bit, a step further, right, 50% from the rural, from the urban area, and you actually look at the age group that is actually really being productive in terms of the different industries, it's a mere 10 to 15% is actually coming from the urban area. So you ask me, this is actually still going to be a challenge for us today in all manufacturing, regardless of oil and gas, F&B industries, water, you name it, right? And of course, the other one that's actually really key is supply chain, right? Now, with the pandemic situation, traditionally, most of the Indian manufacturing plants have relied a lot on their supplies coming from China. Now, we all know China started to experience a pandemic situation as early as January, February this year. with the initial lockdown with Wuhan, the whole supply chain go for a toss, right? And this is actually just increasing the challenge that the manufacturing is having today, right? Not only they have to stop the plant, not really because of the situation back then, but it's just merely because there's a lack of supply to actually go in as raw material for the plant to continue to function. So this is actually what the pandemic has impacted for us, especially in India, not to mention the rest of the region in Southeast Asia and some part of Asia Pacific as well, right? Now, the other very common challenge that the manufacturers actually face today is really on how to ensure consistency in terms of the product they produce, how to actually ensure a consistency for the brand, for the different products that they actually deliver, right? The quality of the product, to some extent, some of the products, like for example, pharmaceutical medicine industry, right, where the different medicine has to have a very clear traceability record from the point the raw material arrived to the plant, to the point through the plant itself, and then to the distribution, right? How do you actually trace that? So all these require cost, right? The question is, how do you balance the increasing costs that these industries are experiencing, but yet making sure that it's actually delivered at an affordable end product pricing. So that's really what is actually challenged by the manufacturers today. Now, how the pandemic situation has actually created more impact. Now, like I say, supply chain is the issue, right? And of course, even skills, a workforce to be able to get into the plant itself is an issue, right, for most of us in different countries. So how do we actually enable that to be the plant to continue to manage and run remotely by some of the operators that are managing it today, right? Now, the third one is really about the regulations. Now, nothing new, right? Pharmaceutical, oil and gas, and you name it, right? Automotive and so on. So each and every one of the industries comes with a set of regulations, comes with a set of compliance requirement that they need to adhere to. Now, question is, how do manufacturers today try to continue to be agile, to be responsive to the ever-changing customer demands that is out there? Let me quote one example. With the pandemic situation, we see a lot of plants, right, around the world, right? The very obvious one is really about how some plants actually convert their environment and the facilities to start producing ventilators. That's really needed for medical purpose, right? How some plants have been converted to actually produce more masks because there was a severe shortage of masks, right? Now, question is, how does actually manufacturer ensure their environment is always agile and is able to respond to all this changing environment? So these are all the different operational challenges. All I can say is that the pandemic situation, where most of us will need to work from home, just accelerate a lot of the gap in terms of the challenges to be addressed much faster, right? Because today you can't operate a plant remotely. You can't operate a plant by sitting at home. So all these are actually driving the changes. Okay, now, so in the new norm, working from home, right? Basically, what is really needed and what a lot of plants out there are really thinking about, right? Having real-time information is key, right? Having a remote access capability to the plant is key. And of course, with a remote access requirement, that also will drive up the need to make sure that all the access to the plant is actually secure. So these are very key, because without that, the last thing you want to have is to have a plant to be compromised by cyber attack, right? And the plant is actually again affected, will in turn be affected by some disruptions on the operations itself. So all this is really driving what we call digital transformation, right? And of course, with this, there would be actually a push for plants to invest more in terms of having technology that is enabling having remote management, remote monitoring, and also secure access to the environment as well, right? And of course, what is actually also important is to actually make sure that the supply chain part of it is taken care of as well, right? Now, a lot of plants and a lot of manufacturers in India are starting to look for alternative supply chains closer to their environment, closer to their ecosystems, where they can actually get supply chains as reasonably priced enough, yet with a good quality to actually allow them to continue their operations now, to actually overcome the so-called supply chain limitation coming outside India as a country, right? So I think that is really what is driving. The new normal is driving what the market, is demanding, right? Now, with that so-called transformation that is being driven, what is really affecting, right? Of course, there will be investment that is actually needed for the workforce, right? In order for a plant, for a manufacturer to allow remote operations, remote monitoring, there will be new devices, appliances needed to be invested for this workforce, right? Be it from smart, from technology standpoint, for the plant, having investing automations in the plant, or even having some smart devices that some of these operations can be done from home, right? A lot of operations can be enabled that way. And today, the technology is ready to allow that to happen, right? And the other thing that is actually that needs to actually relook at is also we all know, right? We still have a big population of baby boomers. Now, I believe most of you would know what is meant by baby boomers. So baby boomers are actually a group of population that is probably at the age of probably 50 to 60s, right? And they were born really post World War II. Technology to this group of people is really, I would say, the adaptation to technology for this group of people are usually a bit low, right? And I think there have been a lot of initiative in the market that is actually done to help them to reskill, so that as the transformation take place in the manufacturing space, where it is actually relevant to them, they would need to actually be able to adapt to the new technologies to be used, right? Now, of course, the third one is really about, just give me a second. It's okay. Okay, the third one is really about the investment for remote manufacturing and access, right? Control the complex of the operations in remotely and so on. So with the transformation in the industry, right, more and more data are being captured right at the floor plan, right? And with the introduction of more sensors around the plant, more automation of the plant, there's a lot more data that is really extracted from the plant itself. With that, there's also a need of additional systems and platforms to actually take care of how do you manage the information, how do you harvest the information. Some call it, machine learning, some call it artificial intelligence, to make sure that the information is either monetized, meaning converting more money to the company, or the information is used for the longevity of the investment of the plants that that have been actually made, right? In terms of extending their lifespan, making sure that they are proactively managed before any breakdown, and so on and so forth. So this is actually what is one of the transformations that a lot of plants are actually doing as well. And of course, with that, there's also with automation involved, there's also incorporation of different new workflow processes as well. So all this is really happening, right, in terms of new investment, new technologies, and how do you harvest the information through the data that is really driven out from the investment, right? Now, moving on, right, then this is where this is actually what we call driving down to the digital technologies, the digital transformation itself, right? So you think about what I've gone through just now again, right? From the challenges that the different manufacturing plants are having from operation standpoint, to how pandemic is driving working from home, to the investments in terms of new tools, new equipment, new technology, and how to digitize the whole thing, right? How to actually digitize down from sensors all the way up to the SCADA systems, control systems, and then all the way up to the ERP layer before the business units can look at the different data points. So these are all driven by digital technologies. And as you know, with more and more data being harvested on the ground, on the plant floor, there will be a need to have more compute power at what we call the edge, at the plant floor, right? In the past, some of this compute and the processing is done in the plant itself, in the manufacturing plant itself. But with the increase in data that is being generated, the processing ability that is being that the current facilities can cater for is really getting overwhelmed, right? Hence, you can hear, if you read out in the different so-called trends in the market, you can hear that there are some manufacturing plants that invest in technology by putting some of this data into cloud, right? What Professor S.P. Singh was mentioning, and of course, that would cost quite a lot from a pure bandwidth perspective. Now, how do you actually balance between pumping all data across from the plant itself to the cloud versus having some of the compute power being processing some of the data in the plant itself? So that's really where this whole digital transformation is actually driving, is where the edge technology is coming up, is where the edge computing is coming out, and that's the whole reason why this whole era of transformation is happening. Okay. Now, talking about digital transformation at the edge itself, right? It can happen in any industry, right? It can be in oil and gas. How do you actually monitor the pipeline? Be it you actually transport the crude oil, transport LPG, and so on. It can happen in rail and transit, right? In the train systems, right? India has one of the most vast covered train systems in the whole world, right? How do you actually transform your edge environment in the food and beverage manufacturing plant, right? How about transforming that in the mining area as well? So that's actually, it could happen in different ways, right? And of course, one of the key premise that the edge compute is actually able to deliver is, first of all, data collection, right? How do you collect all the increased data that you harvest from the different sensors, data collection itself? And then, of course, followed by data analysis, right? As far as the trend today is, most plants or most solutions and transformation new landscape would recommend a lot of preliminary analysis to be carried out at the edge itself, right? And because of that, the computing power at the edge require much more powerful equipment, right? Hence, allowing immediate analysis to be done at the edge, allowing immediate actions or reactions to be taken at the edge. For example, if the data shows that there's a leakage of a pipe somewhere, right? The edge computing will pick it up. You alert the operators as managing that site or remotely managing the fault immediately, rather than transmitting this to the cloud or transmitting this to the centralized data centers before the analysis is being done. So it cuts short a lot of time in terms of analysis. You also reduce a lot of bandwidth in terms of what you need to send back and forth between the sensors to the analysis and back to the operator that is actually supposed to react to the situation. Now, at the edge itself, there is also some expectation in terms of data storage. Would not be big, it will not be huge, but it's actually a data storage sufficient to allow the analysis to take place before a consolidated view is actually transferred up to either data center or the cloud itself, right? Now, like I say, it can be in remote locations, it can be in sites where there's no IT skills. So there's actually a very common so-called definition on edge, because today most IT skills are usually only deployed in centralized locations, centralized data center, centralized operations, and so on and so forth. So to have hands and legs with IT skills at remote sites are usually a challenge, especially for countries as such as India, right? And of course, Edge can actually take care of multiple applications to run. I'll share a little bit about it later on. And with some unique security needs so that it is not exposed to any cyber attacks. So this is really important, right? Now, moving on, this is how we see edge will look like, right? Edge computing will look like, right? At the bottom layer, this is really where I would call the floor plan is, right? Where the actions are really taking place, right? Where the sensors are deployed. It can be on an oil rig, it can be a so-called wind turbine, it can be on a tractor or machines, right? Machines that actually produce maybe your FMP products, or machines that produce your capsules in the pharmaceutical plants and so on and so forth, right? Now, edge infrastructure is really the layer of infrastructure that sits between the devices and the enterprise application, right? The enterprise application could be your ERP, enterprise resource planning tool. It can be your analytics. It can be your supply chain tools, right? Or even asset management, or even up to things like, your demand tools, as well as product lifecycle management tools. So this is really how it look like. It's the intermediary points between the sensors on a floor plan to the enterprise environment. Now, like I say just now, why is it really needed? So again, you look at edge, can be IoT devices, can be edge devices, and so on. It is expected that the edge devices will actually produce a lot of data, right? In fact, IDC projected that as of last year, almost 40% of the edge data is actually managed and analyzed and processed at the edge computing layer itself, which is the middle, right? And what benefits does it give? First of all, we reduce the bandwidth that's needed from the site all the way to data center or cloud, right? It actually also allow faster processing speed, right, between the device and the edge computing as well, right? Yeah. So really, what's really more and more happening now, instead of having analytics done at the so-called data center, a lot of the analytics are actually pushed to cloud now. So, and while actually the use of edge computing would increase to actually drive more and more preliminary analytics to be done and preliminary assessment to be done at the edge itself. So that's actually what is really happening. Yeah. Now, quick one in terms of what would be a 3 quick win strategy at the edge, right? How do people get started, right? So I'm going to use 3 examples for this 3 quick wins strategy. Okay. First one is really about consolidation strategy. Now, for those of you who are familiar in the IT world, consolidation, virtualization has been around for the last 10, 15 years or so, right? Where the footprint of physical compute power has been reduced significantly, right? Instead of having physical servers to manage individual applications, the footprint is actually reduced by going through the virtualization process by consolidating various applications into a more powerful compute, right? So this is happening as well at the edge, right? This example that I'm using here is really about a customer in the US, Buckeye. Buckeye is actually a oil producing company based out of Virginia and West Virginia and Ohio. So they have been operating around 50 years now, and most of the applications has been tremendously aged, right? Technology-wise, is a sprawl, right? And of course, that also comes together with extremely high cost of maintenance, right? Because they're old, it's difficult to maintain, and for them to scale out, right, to actually expand the capability is also a limitation based on the current technology. So what they have done is they have embarked on a consolidation project with Stratus, right? And they have actually started to virtualize and containerize as well, right? The different applications that they have, put them into smaller footprint, right? So that you'll simplify how they can manage the different software they have, be it from a version control perspective, be it from a deployment perspective, be it from a patch perspective, and so on. So this is actually a very good example, right, on how customer can actually do to start their journey on the edge itself. The net outcome of this customer is really they simplify the whole technology stack, really, and of course, very importantly for them is a cost reduction overall, right? In terms of having the technology being deployed to different part of the field, and as you know, in an oil and gas world, a lot of the sites are very remote, where IT skills are extremely scarce. Sometimes it takes days to deploy an engineer to be on site. So with a reliable edge technology solution, they're able to contain that, and they're able to maintain the environment to be more available, hence more productive overall. Okay. Now, this is the first strategy, quick start for edge transformation. The second strategy is really about standardization. Now, just quote an example about a ISP called Schneider Electric. So in Schneider Electric, they do provide building management software. And I believe you may come across them. They have a lot of deployment in India as well, where they have a system platform to control the air conditioning of the building, the lighting, the electrical, the UPS, as in uninterrupted power supply of the building, and so on. So what Schneider Electric have done is really standardize a choice of technology at the edge to be deployed across all their sites, all the projects they want. Now, what does this actually benefit them, right? First of all, they actually get away from the difficulty in terms of managing the life cycle of the different equipment they have for the customer out there, right? And of course, you also have, with standardization, because everything is more like a cookie cutter, it's a lot easier to deploy. In terms of cost of deployment, it's a lot cheaper. And of course, from an end user perspective, there's less customization, hence the cost of a project from an end customer perspective. So with a right choice of technology partner, the edge computing is actually easier to repair and easy to maintain. Hence, the so-called long run maintenance charge cost is actually more predictable, more manageable, to some extent also more cost effective. Yeah. So this is actually a benefit of standardization. The second strategy that some of your edge customer can actually embark on to get started with edge transformation. Okay. The third strategy is really about a strategy on how to maximize connectivity and integration, benefiting a so-called technology, rather the compute power between cloud computing as well as edge computing. And for this example, I've used a solution that is actually put together by Aviva. Aviva is actually one of the world biggest software solution company for the industrial automation space, where the software is so powerful, where it actually help to provide a unified control center for the different industries, be it from a wastewater management perspective, be it from oil and gas perspective, you name it, F&B, food and beverage, and of course things like dairy farms and so on and so forth. So they actually have a lot of install base around the world, and they are one of the largest SCADA solution provider around the world as well. Now, for this example, they have actually put together a solution where it enables the connection of the on-premise, which is like on the site of the plant, communications between the site as well as the cloud, right? Now, as I mentioned, cloud computing will be here to stay, be it from an IT world or be it from operational world, right? But of course, cloud computing is more used for analytics, it's more used for machine learning, and so on, right? Which is something that you can do probably with a longer turnaround time. Whereas edge compute will require to be processed immediately, right? You turn around the decision, you turn around the analysis, you turn around a dashboard visualization immediately to the people that is on site. So Aviva has put together a solution where it allows a collection of data consolidated and have it connected to the cloud. In this case, they partner with Azure using the IoT stack, right, and where it actually allow a seamless connection between the plant as well as the cloud itself. Now, of course, some of the things that is their concern when they put together is really about security, because security is something that we are all very concerned about. I'm sure you have read about different reports where even certain government ministries are compromised. Some plants were compromised by actually having it shut down for weeks, having things, equipment to be replaced just because of security exposure. So security is definitely key. So in this case, Aviva have chosen a bundled solution where they have their software stack loaded with edge technology provider and which is actually coming ready with some secure stack and even allow some of the edge computing to be, edge processing to be conducted on premise before it's sending to the cloud. And of course, vice versa, from the cloud back to the premise as well. Right now, what are the benefits that this allow from a connectivity and integration perspective? It allows the deployment to reduce on-site service costs, right? Because you're actually pushing a lot of workload to the cloud, right? And of course, it's one of the ideal way to deliver analytics solution as well. So, so this is a three quick win strategy for us, right? First of all, consolidation through virtualization, right? 2 is standardization, and 3 is about how to make use of connectivity and integration between different platforms. And in this case, it's between the on-premise compute power as well as the cloud computing. So this is actually what we recommend for a quick win. Yeah. Now, with all that said, right, what do people look out for when it comes to a cloud computing provider? So Professor S.P. Singh was talking about bandwidth just now. We were talking about some processing, and it was also talking about log time, right, and so on. So let me just share with you. With edge compute, that comes with some challenge as well, right? I mentioned a few times security is a key challenge, right? Really, security is a key challenge. I mentioned enough. There's so much threat out there, right? In terms of different virus attack, right? Different cyber attack, and there's so many companies we are aware of, though we cannot disclose, that have been affected by it, right? So security is definitely a key, and of course bandwidth, right? Very, very important. How do you balance the bandwidth that you will be using? Because bandwidth in some countries equals to amount of money that you'll be paying, right, between your plant and your data center, or between your plant and the cloud, right? The more data you transmit between the two locations, the more bandwidth will be required, right? And of course, in certain locations, bandwidth may not necessarily be a luxury, right? You may not actually necessarily have enough bandwidth to actually allow certain amount of data to be transmitted seamlessly with very low latency, right? So that is actually the other area that a lot of our customers who are considering edge transformations that is looking into as well, right? Now, of course, not only bandwidth, right? Latency is also key. The quality of the network that your plant is actually in, right? There are times where some applications will require very, very low latency, right? Even like sub 10 millisecond kind of latencies to make sure that the data is actually processed, turned around quickly, because the plant is actually operating extremely critical operations, right? So that is actually something that you need to consider as well. And of course, the rest of it will be data sovereignty, the WAN reliability, and so on and so forth, right? So these are certain things that we should look out for. Now, our recommendation is this, right? The key requirement for edge computing, first of all, it should be something that is simple to deploy, right? Simple to set up, simple to provision. Very importantly, because usually the plants deploy it to remote area or even to areas where there's limited IT capability. So it has to be easily managed, right? What is also important is that it should allow easy expansion. A lot of so-called plants that I've seen myself today is that they deploy a choice of deploy the edge environment with a choice of very simplified technology, but that with very limited expansion capability. So this is something that we always remind our customer when it comes to the choice of technology. Do remember the plant. There's always room for plant expansion. So that is something that we always remind our customer. Now, second important criteria is making sure that the choice of technology chosen is allowing that to protect your environment. So technology that comes with embedded cybersecurity features, right? And that will allow the environment not to have any unscheduled downtime. We all know about scheduled downtime. We all know that when you need to upgrade certain hardware, many times you need to schedule a downtime. Essentially, what does this mean to a plant, right? With a scheduled downtime means a scheduled operations, a reduction in production, reduction in yield. Hence, net is actually a reduction in profitability and so-called bookings that the companies can have. So having a edge technology that allow them to have no unscheduled downtime is important, because they have a reliable technology to help them to do that, so that their plant can continuously operate, right? Continuously run, and the productions can continue, continuously operate. Now, the third feature is to look out for is really to have technology that is autonomous. What does this mean, right? Autonomous, right? Where the technology can allow to have failure prediction, meaning you are proactively monitoring the environment. You're predicting if there's there's a failure that's going to happen in the near future. So you would like to look for a technology that allow you to have that failure prediction. Right? And of course, we all know, right? Windows have their software patch almost every other month, right? Likewise, for Linux, for VMware, they do have their software patches. Of course, this is actually at the OS layer. Right? Now, from a software application perspective, depends on, doesn't matter whose software the plant deploy. They can have software patches anytime or software upgrades anytime, right? So you want to choose a technology that allow an easy update to the technology as and when all this happens. Now, what's happening today in most of the older plants? They have to, again, schedule a downtime, right? Upload the new software, making sure that whatever availability configuration is done, simulate that, then you bring up the operations, and that is actually a loss of income for company. So you want to choose a technology that allow you to have easy update. Now, last but not least, you also want to have a technology that allow you to actually have a remote monitoring capability, especially in the situation today where all of us, I believe, are still working from home, right? Taking classes from home to some extent, right? Having a remote monitoring capability is key. Without that, you wouldn't know what's happening in the plant, even though it may be running continuously. So this is very, very important. Okay. Now, moving on, right? Let me just take a step back, switch gear a little bit to talk about Stratus and what do we do, right? In Stratus, we help all our customers to minimize the risk, right? How do we minimize that? We ensure our platforms that is deployed out there is always running on a 24/7 basis, 365 days a year, right? We have platforms deployed across many industries, right? Be it from manufacturing perspective, which we talk about, oil and gas. I mentioned a little bit about that. Utilities could be power, could be water, right? That's what we do as well. Transportation, we have a lot of deployment into metro systems, right? Into airports, right? Into port, as in for the ships, right? So we have many deployments in that. Right? And what is really also coming up is smart machines, smart buildings, smart cities, you name it, right? And the other thing that I actually want to highlight is that we are also very much into the payment space, right? In the banking sector, right? So that's what we help our customers to do, right? We have been around for 40 years, right? This year, in fact, we're celebrating our 40th anniversary. Unfortunately, with the pandemic situation, we are not able to gather together to have this celebration. But we have been helping different industries to protect lives, to save their assets, and more importantly, to protect their revenue since 1980, right? We are a US-based company based out of Maynard in Massachusetts, right? And we are present across the whole world. Yeah. Now, when we started off, a little bit of history about where we started off. We started off with a proprietary fault-tolerant computing platform. So in the same days with the IBM mainframes, in the same days with the Tandem, right? If you have heard of Tandem, which is now acquired by HP Enterprise, it's being rebranded as HPE Nonstop. So that's where we started, right? IBM is proprietary. HPE Tandem today is Nonstop today is still proprietary. But we have moved since in the early 2000s to actually move to an open system-based fault-tolerant hardware and software solution provider. And of course, since 2018, we have actually ventured into a completely new product line, which is what we call a zero-touch edge computing, the ZTC solution. As you can see here, we are very well recognized, be it from ARC perspective, from Forbes, Gartner, and so on. So that's actually a bit of track record of what we have done. So yeah. In terms of manufacturing, right, we are across both continuous and discrete manufacturing plants, right, be it from textiles, right, fabricated metals, machineries, and so on, down to continuous process factories like oil and gas, refinery, petrochemical, and so on and so forth. And the different logos that you see on the right-hand side are just a sample of some of our customers around the world. Yeah, be it from a pharmaceutical perspective, you see Pfizer and so on and so forth, right? And then you see Exxon, oil and gas. You see Bosch, right? Even Samsung. So these are very familiar brands that you may be seeing, like Hershey Chocolate, Heinz. I'm sure all these are pretty familiar logos that you have seen. So we are really across the different industries from a manufacturing standpoint, right? Now, this is actually really where we play, right? Very specific to a manufacturing environment, very specific in the industrial automation environment. You can see on the left-hand side is really the different layer of the SCADA deployment, right? Where you have level 0, level 1 is where the plant floor is. It could be in a plant, it could be in remote locations like gas pipes and so on and so forth. And then level 2, level 3 is really typically in a control room, right? And then anything above level 3 is what I call just now the enterprise applications stack, right? Where the IT will come in, where the enterprise resource management ERPs coming in, and so on and so forth. So we have been supporting various brands application, right? Be it from Siemens, be it from Rockwell, be it from Schneider Electric, GE, Johnson's Control, you name it, right? So these are just a few of the software applications that has been endorsed by using our technology. Now, you will see that for the two area that we play in, right, in the control room area, we have enterprise grade fault-tolerant server where it's built for remote data centers. It supports different OS. It is highly configurable. And of course, in the plant floor perspective, This is where the zero-touch computing works. Ruggedized, suitable for just extreme weather conditions, extremely serviceable remotely, and of course embedded with cybersecurity and so on and so forth. So this is really how we have our different product range position in the manufacturing vertical, right? Now, just zooming a little bit deeper into the two product range that you see. So the one on the left is what we call FT server, fault tolerant server. Basically, it offers 99.999 availability. So for some of you who may be familiar in the telco world, it's called a carrier grade. No, it literally didn't really, it won't go down, it won't spoil, it will actually so-called bring down a service. So it's actually really IT standard enterprise grade. Uses a Xeon chipset, and it supports all open OSs. So that's actually the FT server. And this is really the one that's commonly deployed across most of the brand names that you see just now, right? Now, on the right-hand side, is really the ZTC, what I call zero-touch compute, ruggedized, built-in for industrial edge environment. Is self-protecting, monitored by Stratus if you need to, right? And it actually comes virtualized as an environment. So you can just install application immediately when you receive the equipment itself. So that's just a short intro of the product. I won't go into much, but this is really a quick overview about the different features of the solutions we have. Now, right across integrated redundancy, it's pretty much a pardon my language, idiot-proof kind of setup. So you plug in, you swap out a 14 node, and you will continue to run as it is, right? Supports open systems, lower TCO here stands for total cost of ownership. Security is simplified. It supports industrial interoperability, so meaning it can actually be integrated to different industries very easily. All of them supports remote manageability. And of course, very importantly, in the events, there are certain part replacement. It is automated part replacement. So the users or the plant, in this case, do not have to worry too much about anything. Yeah. So that is actually our features. And of course, if you compare us, right, which is on the extreme right-hand corner, we are playing in the fault tolerant arena, which is the 99.999 availability, literally no downtime or data loss. Of course, in the market today, you have a standalone server, you have a cluster environment, right, where you have 2 nodes, and of course, you have virtualized environment where you can have 2 or 3 nodes. So these are all not failure prevention; they are failure recovery. For us, it's failure prevention, which is extremely crucial for a lot of the critical business application today in the industry. Okay, now just a bit of time check, DCOM. I know we are at the top of the hour. So how do you want to do this, DCOM?
At the very outset, let me thank you for sharing the insight and how edge technology is so very critical to ensure continuous operations during this new normal. And we are really thankful for that insight. And we would have loved to hear more from you in this regard, especially on the lines of food and beverages and maybe the tea sector, oil we have here. It will be something more connection. However, we have a few questions coming in from our students at this moment. So will it be fine to take them now?
Sure, definitely.
The first thing is they wanted to ask was, how reliable is the solution in an offline state?
Okay. Yeah.
So,
It's okay. Let me take that question. So because our solution is fully autonomous, right?
right.
When it says offline state, meaning there's no connection from the outside world to the plant, I presume. That's how I will interpret the question, right? So you will continue to run. The only thing that you will not have is a connection, be in this case to the cloud, or a connection to the data center, which a lot of plants is still doing today. So whatever is actually loaded into the systems will just continue to run autonomously. Now, of course, if under the very unforeseen circumstances, should any parts actually fail during that period of offline, the systems will still continue to run because all our solutions come with fully redundant hardware. So there's always a backing out of each other. Even though if there's any part failure, our system will just continue to run as per normal. So as far as end user is concerned, he or she will see that there's nothing wrong with the system.
Great. The other one that's coming is, will edge computing require any changes to the organization's operating model? Will there be any changes?
Well, I would say it's yes and no. Well, traditionally, edge computing, let me not call it edge computing. Traditionally, the compute resources on the plant is usually managed by either the OT, as in the operation technology, the plant managers, the plant support team, and so on. In some plants, it is managed by IT. But with edge computing, right, first of all, once the system is commissioned, the need of IT skills is almost zero. Yeah, because it will just be running the business application that's actually installed. Unless there's an upgrade, then there's a need of intervention. Even when there is a fault detected, right? So long as the customer, in this case, the end users, decides to connect to our remote monitoring center, right? We will receive all fault tickets. We will diagnose the tickets, the issues, and then today, almost 90 to 95% of all fault reported can be resolved remotely. That means there's no intervention needed. Where there is a parts needed for replacement, we automatically ship the parts on site. So if everything can be done hot swap in the production environment, you don't need to actually plan for any scheduled downtime. You just take out the faulty part, replace it. It will just continue to run.
Great. And I'm sure the next one coming up is a little curious one.
Sure.
This looks like a very curious question. Well, what is the size and cost of the engineering team required to build and later maintain the edge solution?
When you say engineering team, would this be the engineering team of the customer?
Yeah.
Okay, well, that really depends. And it depends on the size of the plant. I just hear about now what Pfizer has gone through in the last 4 years journey. They have actually embarked on a digital transformation journey. Of course, it's not only about edge computing. You actually talk about the introduction of additional sensor and telemetrics on the plant itself, down at the floor plant, right? And then how you collate the different digital silos, right? You have maybe one plant running some liquid medications and so on, and the different raw ingredients, the different raw materials that it's using to actually produce the medicine. So there is a complete 4-year journey, right, that they have embarked on for the digital transformation, and a lot of investment in the edge computing as well. So really depends on the size, right? Mid-size, large size, and also depends on the industry. Some of the plants would have discrete operations, right, where you have different chunks of so-called assembly or processing done in certain part of the plant, and then move on to the another one, completely so-called non-integrated. Some of them will be really end-to-end, continuous manufacturing. So it really depends on what kind of plant, the industries, and the size of the setup as well.
Great, and thank you so very much. And I was wondering if Hirok would like to ask a question from his end. Hirok, if you're there online with us, from the cell, from the institution's Innovation Council. Over to Hirok, if you're there.
Yeah. Good afternoon.
Hi.
Hi, myself, Hirok. Can you see me? Yeah.
Yeah,
My,
we can see you. Yeah, it's a
so,
little bit blur, but we can see
yeah,
you.
thank you. So actually, uh, how this edge computing can change the IoT platform? Means how? Hmm.
Okay. Well, okay. So here, I would say, see, IoT platform is a very broadly used term, right? It can refer to anything, right? Anything that could be from a preliminary data aggregator from the sensors, right? I mean, let me put an example, right? IoT platform could be a platform where you aggregate lighting sensors for the different lamp posts around the area. That could be an IoT platform, right? IoT platform could be also nowadays we have IoT platforms that has got some intelligence built in, meaning there are certain analysis that you can process in the platform itself. So again, really very broadly used term can refer to many different things. But what's important is this, right? All this data that you actually collect, right? Typically, you can feed it. You can call it IoT platform. You can feed it into an edge compute, right? So if you ask me, it can be used interchangeably, right, between edge computing and IoT platform. Depends on the functions that the IoT platform is delivering. Yeah. And the other thing I also want to share is this, right? As you actually explore more in terms of edge computing, today, even like ISVs like Schneider Electric, they talk about near edge data center, right? Or edge data center. So what does this mean, right? It can be a data center that is actually built nearer to maybe a ecosystems of manufacturing plants, could be industrial zones and so on and so forth, where you host a lot more information coming in from the plants near to you. So they call it near edge data center, or they call it edge data center. You can load different SCADA applications, analytic applications in that environment. Process process the necessary data, right? For those that you need to feed back to the plant, you actually do that. And then for those that after processing, after you reduce the kind of data, you can actually send it back to the main data center or even
12:30 के बाद आप लोग चले जाना रेस्ट के बाद रेस्ट पे 12:50 पे आ जाना सब लोग तो मैडम ज्वाइन करेंगे
Request all the participants to please mute your microphones. We can hear some out noises. Maybe it could not be directly known to you, but if you can all mute your microphones. Thank you. Sorry about that.
No
Sorry
problem.
about that.
Yeah, no problem. Yeah, I hope I understand your question, Hiro. Yeah.
कोई सिंथेसिस बता देगा इसमें कौन से उसकी सिंथेसिस है
I believe that. Sorry about the disturbance once again. And with also the clock ticking at 12:15,
Yeah.
Mr. Shivanand Wagle, Hirok, and all the participants from the
Thank you,
Mr. Council, and which
So-
runs the Ministry of Human Resource and Development Organization. I think with everyone's consent here, let me.
So DCOM.
Yes.
Yeah. So maybe as a last slide, if you allow me, in summary, yeah, I just want to highlight that digital transformation at the edge will continue to accelerate. I think it's definitely here to stay. The pandemic situation in some countries have accelerated this process. So that's something that I want to highlight. And of course, some of these plants that we talk to nowadays, they find that this is a better time. There's no better time than now to look at their digital strategy. So really reprioritize, the essential operations and modernize those areas. So do reach out to us. You have two email addresses here. So I'll send this slide across to you, DCOM, later for your internal sharing. Of course, my email and Shivanand's email is also available. So with that, I want to just wrap up my session on my end. Yeah.
Thank you once again so very much.
Thanks. Thank you very much.
Shivanand Wagle. Thank you Doc for making it possible. I also like to thank our IT team here in the university, along with the Vice Chancellor's office, Pahi and her team for helping us making this possible. And thank you once again everyone at the IT team here in the university, and also to all our colleagues and dear young students. I am sure it was quite an eye-opener and how very critical it is to have edge technology to ensure continuous operations during this phase of new normal. And with that, we'll surely have a few more sessions in this regard, as Guwahati City is also planning to become smart in the days to come. And we know how important these kind of technologies, the role they play in ensuring the development take fast at a very steady pace. I once again thank everyone for participating here, and please stay healthy and safe. And thank you once again from the world of university.
Thank you very much.
Thank you, everyone.
Thank you. Bye bye.
All right. Stay safe.